this assessment gives us a hypothetical scenario where a chemist attempted to make compound A or B, and the chemist wants to know which one is it. Well, we can use coupling constants to answer this question because coupling constants are going to be variable based on the dihedral angle between them. And so what we've done is we've drawn chair conformations for both A and B, shown here and here. And then if we look at the one for A, we have to ask ourselves, is this the most stable conformation? Well, we've gone ahead and drawn the other chair. And what you notice is that this one is probably the more stable conformation because it puts the isopropyl group in the equatorial position. Well, the dihedral angle here between HA and HB is going to be 60 degrees. So we have a 60-degree dihedral angle in the most stable conformation. A 60-degree dihedral angle is going to give us what we expect to be a coupling constant of 4 Hertz. So if we look at the NMR spectrum and we see a coupling constant between HA and HB of 4 Hertz, we would believe that we probably made compound A. Let's do the same thing for compound B. Here, the first chair conformation that we would draw might be this one, where we have the isopropyl group axial and the methyl group axial. We can do a ring flip to get the isopropyl group in the equatorial and the methyl group in the equatorial. So this is going to be favored by quite a bit because it puts both groups in the equatorial position. Well, now the dihedral angle between HA and HB is 180 degrees, and we expect to have a coupling constant when HA and HB have a dihedral angle of 180 degrees. We expect a coupling constant of around 15 Hertz. So if our NMR spectrum shows a coupling constant of around 15 Hertz, it's likely we would have made compound B.